Hi, this is Nesniewski. The class is Discrete Structures. We're up to section 2.2, which is about logic, but it's really about truth tables. So it's that part of logic about truth tables. Okay, and we're going to do the homeworks. As always, do the homeworks first, then check your answers here. It doesn't pay to just watch me do it. I know how to do the problems. You have to work at the problems, you have to think about the problems, and then do it. So look at the numbers, do the problems, and then come back here and check your answers. Okay, let's get busy. It's actually a lot. Okay, I have to admit it is a lot, and a lot of it is going to be truth tables. That's why we skip so much, the early ones, and we just get a lot to truth tables, so it will be a lot. Let's go. You ready? Give the converse and the contrapositive for each of the following. So let's just remember, if P is Q, and this is number one, if P arrow Q, if that's a statement, the converse is Q. So this is the statement, this is the proposition. The converse is Q arrow P, and the contrapositive is not Q arrow not P. Okay? And we said the proposition is equivalent to the contrapositive, not to the converse. Okay, so let's do it. Okay, P arrow Q and R. So the first thing is P arrow Q, lowercase, Q and R. Okay, so that's the proposition. The converse is Q and R arrow P. The contrapositive is not Q and R arrow not P. Okay? If you want, you can fix this in some sense by doing De Morgan's law. So this becomes not Q or not R arrow not P. Okay? That's the first one. Okay, let's do the second one. If x plus y is equal to 1, then x squared plus y squared is greater than 1. Okay? If x plus y is equal to 1, then x squared plus y squared is greater than 1. Greater than or equal to 1. Okay? That's a statement. I'm not interested in if it's true or it's not true. Is there a comma there? There's a comma there. Okay, good. What I just want to do is write the converse. So the converse is if x squared plus y squared is greater than or equal to 1, then x plus y equals 1. That's the converse. The contrapositive is if x squared plus y squared, instead of greater than, so we want not greater than or equal to, so let's write less than 1. Then x plus y is, let's just write not equal to 1. That's contrapositive. Okay, and so this is A, this is B, C is as follows. Okay, if 2 plus 2 is equal to 4, then 3 plus 3 is equal to 8. If 2 plus 2 is equal to 4, then 3 plus 3 is equal to 8. This is true, this is not true. They have nothing to do with each other whatsoever. But again, in logic we're not interested in, we're interested in the form of the statement. So we want to know what the converse is. The converse is if 3 plus 3 is equal to 8. So by the way, this is false. The converse is if 3 plus 3 is equal to 8, then 2 plus 2 is equal to 4. By the way, that's a true statement. This is a false statement, this is a true statement. Because this is always false. 3 plus 3 is 6. This is always true. False implies true. That's a true statement. Okay, the contrapositive is if 3 plus 3 is not equal to 8, then 2 plus 2 is not equal to 4. Now, this is true. 3 plus 3 is not equal to 8, it's equal to 6. And 2 plus 2 is equal to 4. So this is a true arrow. False is false. So this whole statement is false, and that whole statement is false. This is true. Okay, good. Let's do number 3. Number 3. Okay, so let's just write them all up so we don't have to look at the book all the time. Let's do 3. Okay. P arrow Q, not P arrow not Q, Q arrow P, not Q arrow not P, Q and not P, not P or Q, not Q or P, P and not Q. Okay? Okay, number 1, which is the converse of P arrow Q? And that's Q arrow P. This is so this is the answer to A. Next, this is actually a multiple choice question. Which proposition is the contrapositive of P arrow Q? Okay, and the answer is not Q. So this is not Q arrow P, not P. So this is the answer to B. Okay, great. Which propositions are logically equivalent to P arrow Q? So that's interesting. Which are logically equivalent to P arrow Q? So this is C. This is logically equivalent. This is C. This is logically equivalent. Okay, what else? This is logically equivalent. Okay, I don't see any others. I don't see any others. Okay, anyways, this is not. This is not. This and this is. I don't see how this is or this is. It's not. It's not. It's not. Okay? Very good. So that's C. Okay, good. Now, number 9. That's 3. Now let's do number 9. Okay. Okay. It says, construct the truth table for P or Q and R arrow P and not Q. Okay, so let's just go through it. We have 3 variables, P, Q, and R. So let's put P, Q, and R here. And we're going to rank the truth table. Again, I promise you there will be truth tables on the tests, and there will be truth tables on the final. It's one of the things you definitely have to know. And I won't ask you truth tables about a 2 variable problem, and I won't ask you about a 4 variable problem, but I will ask about a 3 variable problem. Let's put in the possible values: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Again, in the video and whenever I have a board and I don't have lines, I draw that thing just to separate it. Okay, let's do it. P or Q. So, we want to get, this is going to be the final answer. That's the outermost operation. This is the first operation. In order to do that, we have to do this. P or Q, I'm going to be a little bit quick about this. 0, 0, I could make mistakes. 1, 1. This is going to be 1, 1, 1, 1. Okay, let's just do R. So this and R, here's R. So this is going to be, if you don't, we could put in R. Let's write R. 01, 01, 01, 01. So now we do AND. So this is 0, 0, 0, 1, 0, 1, 0, 1. Whoops, don't want that. That's the final answer for this box, but it's not the final answer for the problem. Okay, great. Now let's do P and not Q. We can do P, just copy P right there, 0, 0, 0, 0, 1, 1, 1, 1. Not Q is 1, 1, 0, 0, 1, 1, 0, 0. AND is 0, 0, 0 and 0 is 0, 0 and 0 is 0, 1, 1, 0, 0. Okay, and now we're going to compare this guy and this guy, and we're going to do arrow of it. So ready? 0, arrow, anything is 1. 0, arrow, anything is 1. 0, arrow, anything is 1. 1 arrow, 0 is 0. 0 arrow, anything is 1. 1 arrow, 1 is 1. 0 arrow, anything is 1. 1 arrow, 0 is 0. That's our final answer. Again, I might have made a mistake, but that's the way you do it. Okay, so that's 9. Okay, nice. Number 10 is a nice problem. You could steal it for a test question. Okay, number 11A. Let's see what 11A is. 11A, construct the truth tables for, okay, not P or Q. Okay, well, anyways, 11A, they want you to be careful about parentheses, but we're careful about parentheses. So let's do it. Not P or Q. Not P or Q. Arrow R. Okay, their point is that they want you to see that this not goes on this and not on this. Okay, so we're going to first figure out this. So the truth is they should really write this like this. Let's do that. Okay, and then we have P, Q, R, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. The dots, just to keep things from moving along, they wave otherwise. Okay, let's do this. This is OR. So we're doing this, OR. So this is 0, 0, anything, 1, 1. This is P and Q like that. 1, 1, 1, 1. Not of that, so let's negate this line. So this is the exact opposite. 1, 1, 0, 0, 0, 0, 0, 0. Great. Okay. Now, next, R. R is 0, 1. And I'm going to show you a trick here. Okay? You shouldn't do this in real life, but I'll show you the trick. The trick is as follows. I should really finish this R and then do the whole thing, but watch. This is called lazy evaluation. 1 arrow 0 is 0. 1 arrow 1 is 1. All the rest are zeros, so all this is 1. Finished. I don't even have to look at anything. 0 arrow anything is 1. So that's what we have. That's the final answer. But let's just finish it off. Not 0. R is 0, 1, 0. Here I'm doing 0, 1, 0, 1. Okay, and this finishes it. Okay. I just want to show you what the rest of 11 is, and perhaps you should do it. They also want you to do this. P or Q arrow R. Okay? And then what you do this. Now what's this? First you do, again, and this is a logic, but it's a math class also, you do this, then you do what's in parentheses, you do this, then you negate that, and you'll see it gets a different answer. I want you to see that the different answers. So you have to be careful with your parentheses. Great, that's 11. Let's do number 12. In which of the following sentences is the or inclusive, or is the or an inclusive or? Okay, as opposed to an exclusive or. Okay, so that's nice. So let's do it. A, B, C, D, E, F, G, H. Let's read the question again. In which of the following statements is the or an inclusive or? Choice of soup or salad. So you go to a hotel, you want a soup or a salad. Okay, I don't think you're allowed to say, well, if it's in a restaurant, you can't say no. So that's an exclusive. Okay. To enter the university, a student must have taken a year of chemistry or physics in high school. Well, obviously, you can enter university if you took both. So this is an inclusive. Okay. C, publish or perish. So that's something in academia. They tell you have to publish, or they fire you and you go to hell. Okay, so publish or perish. It's an exclusive or. Okay, you're not going to publish and perish, because if you publish, then you're going to go to heaven. So that's exclusive. Okay, D. Experience with C++ or Java is desirable. You're looking for a job. They want to know, do you have experience with C++ or Java? So experience with C++ or Java is desirable. That's an inclusive. I want you to have both. If you have both, you're great. So that's the question. You always say, okay, what happens if both of them? If both of them is good, then you have inclusive. The task will be completed on Thursday or Friday. You can't have one task being completed on Thursday and Friday. Completed means it's finished, so that's an exclusive or. Okay, F. Discounts are available to persons under 20 or over 60. I never met somebody who is under 20 and over 60. So that's exclusive. Such a person doesn't exist. G. No fishing or hunting allowed. This is a little bit more complicated. No fishing or hunting allowed. So are you allowed to do fishing and hunting? No. You know what? I'm not sure about this one. No fishing or hunting allowed. And you're not allowed to do fishing and hunting. So it's I think it's inclusive. Okay, the school will not be open in July or August. The school will not be open in July or August. That's inclusive. Okay, because it won't be open in both of them. That's great. Okay, great. So sometimes inclusive, sometimes exclusive. Great. Next, 13. 13 is where we actually get into symbols about exclusive or. Now, in my lectures, I actually talked about exclusive or, but here it's not talked about in the book beforehand, but it's used as an exercise. So we'll go through it. The exclusive or connection, computer science say XOR, is defined by the truth table like that. So let's do it. P exclusive or Q. You know, they're using small letters, we should use small letters. Okay, P, Q, okay, is, okay, it's almost like or in the following sense. The only thing is, it's not allowed both. So that's the only difference between the exclusive or and the inclusive or, is when they're both true. In the inclusive or it's true, and in the exclusive or it's 0. Okay, good. show that P plus Q is the same as not P arrow Q. So let's do this. Okay, so we can do probably the whole thing right over here. So it's not P double arrow Q. Let's do that. P double arrow Q is true when they're the same and false when they're different. Just look at that. Okay, so this becomes P double arrow Q is true when they're the same, when they're both 0. Here they're different, here they're different, here they're this, here they're the same. 1 and 1 is the same. Not of that is 0, 1, 1, 0, and that's exactly the same as this. So that shows they're the same truth table. Next, construct the truth table for P plus P. Okay, so let's do that. P plus P only has one variable, P. Okay, 0, 1. Okay, and we could just put it in 0, 1, 0, 1. Okay, truth table plus, here they're the same, 1. Here they're the same, 1. So P exclusive or P is always true. Okay, great. Okay, now we want a truth table for 3 variables with the exclusive OR. So let's do that. Okay. P plus Q plus R. P QR 0, 0, 0. I wish I had a stamp that did this. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Dot, 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 dot. Okay? Do the plus Q first. So let's do it. This is 0, 0, 1, 1, 0, 0, shoot. Sorry, P and Q, P or Q, they're both 1 and 0. So this is just like OR, 1, 1. Here they're the same, 1, 1, plus with that 0. So it's like that. Okay, great. Plus R, let's just write R. So R is 0, 1, 0, 1, 0, 1, 0, 1. Okay, and now we do plus of that. 0 plus 0 is 0. 0 plus 1 is 1. 1, 0. 0, shoot. 1 plus 0 is 1, 0, 0, 1. That's our final answer. Okay. Very nice. Just want to say, one of the questions I can ask is exclusive or associative? So what that would mean is this the same, is this logically equivalent? Oh, we know how to write logically equivalent. We do it like that. Is this logically equivalent to this? Okay? That's a good question. It's a good test question. Okay? And so you have to make a truth table for this and a truth table for this and see if the truth tables are the same. I have no idea. Good. Next. Okay? Last part of number 13. Construct a truth table for P plus P plus P. No, we're not going to put it over here. We're just going to do it like this. P plus P plus P associated this way. Okay? Short truth table because we only have one variable, 0 and 1. So this is 1, 1. We did this 2 minutes ago. P plus P is 1, 1. Okay? Plus P, so this is 0, 1. So this is 1, 0. 1 plus 0 is 1. 1 plus 1 is 1. So we get that. Okay? So that's interesting. That is logically equivalent to not P. Okay, good. Next, 16A. Write a compound, oh, I'm sorry, I don't want to put my back to you. Write a compound proposition that is true when exactly one of the three propositions P, Q, and R is true. Okay, 16A. Okay, so it's a funny thing. We have three variables, P, Q, and R. 0, 0, 0, 0, 0. 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1. 1, 1, 0, 1, 1, 1. Okay. We want to make a formula where we want to make a formula here that's true in exactly these places. When this is true, when this is true, and when this is true. Now let's just read the English again. Write a compound proposition that is true when exactly when one of the three propositions P, Q, and R is true. Okay. So basically we want a proposition that's true here, false here, true here, false here, true here, false here, false here, and false here. That's what we want. Okay? So it's a funny thing. We're going backwards. Usually we give the proposition and say, okay, find out when it's true. Here we're told we want it to be true when only one of these are true. Here two things are true. Here two things are true. Here all three are true. Here none are true. We want it like that. Okay, and the answer is cute if you see it once. Ready? Basically, you want as follows. You want not P to be true, and not Q to be true, and R to be true. That's one thing. Okay. Now this proposition is going to be true only here. Only here. Every other time it's going to be false. Okay? Or another thing that you want is not P to be true. I'm doing this line. And Q to be true. And not R to be true. That's here. Okay? Or another thing you want to be true is P should be true and Q should be false and R should be false. That's it. Okay? Now, it doesn't matter how I put parentheses here, okay, because or is associative. May as well put it like this. If you fill this out and you fill this out, the final answer will be under here, and this will be the final answer. Okay? It's a trick problem, but it's used a lot. Okay? The idea is you can control. You want this and this and this. So that's okay. You want this to be 1, or this to, and this to be 1, and this to be 1. Well, that's exactly what you get over here. Okay, so that's 16A. Okay, let's go. Next. Next, 18C. It says prove or disprove. So let's do it. P arrow Q arrow R. P arrow Q arrow R. So this is 18C. P arrow Q arrow R. Is that the same thing as P arrow Q arrow R? Question. Is that logically equivalent to P arrow Q arrow R? Okay, we want to know if these two are logically equivalent. The way we tell if two things are logically equivalent is we put the double arrow there. Okay, we do the truth table for this, we do the truth table for this, and we see if we get the same answer. Okay? Okay, I just want to say before we even start, what is this statement? Well, this statement says that arrow is associative. It doesn't matter how you associate them, how you bring them together in terms of parentheses, they're the same. We have to see if this is true or false. Let's do it. 0, 0, 0. Okay. Okay, let's do it. First do P arrow Q. So this is going to be, we're going to do it a little bit quicker because all these are zeros, so this makes this all 1. Okay, and here is going to be 0, 0, and here is going to be 1, 1. Great. Now R, let's just write down R because it's easier than looking at it there. Okay, 1 arrow 0 is 0. 1 arrow 1 is 1. 1 arrow 0 is 0. 1 arrow 1 is 1. 1, 1, 0, 1. Okay, that's the final answer here. Let's do this. So let's do Q arrow R over here first. Q arrow R. 1, 1, 0, 1. 1, 1, 0, 1. 1, 1, 0, 1. 1, 1, 0, 1. Great. Now P, let's write P, 0, 0, 0, 0, 1, 1, 1, 1. Okay, now do the arrow. We're doing this arrow. We're dealing with this arrow. So 0 anything is 1. So this is 1, 1, 1, 1. 1 arrow 1 is 1. 1 arrow 1 is 1. 1 arrow 0 is 0. 1 arrow 1 is 1. This is almost a tautology, not a tautology because it has a 0 here. Main point is this line, which is the final answer of this, is not the same thing as this line. Okay, so let's be a little bit more formal. This is not the same as this. Okay, let's go through it. Therefore, they're not logically equivalent. Therefore, arrow is not associative. That's an interesting point. Okay, but let's do it. 0 arrow 0. This is the final answer for this. This is the final answer for this. Let's go. 0 double arrow for 1 is 0. 1 1 true. 0 1 0. 1 1 true. 1 1 true. 1 1 true. 0 0 true. 1 1 true. Okay, so they're almost the same except for these two places. Doesn't matter. They're not the same. Therefore, this statement is false. They are not logically equivalent. False. Okay. By the way, that problem has a lot of good statements. Next. Verify the following logical equivalence using truth tables. Okay. So it says 12a. Okay, so now we're up to 19a. Okay, so this was nice. Now we can do a little of this. 19a. Okay, so what's 19a? It says, take the logical formula, 12a, P arrow R and Q arrow R, P or Q. P arrow R and Q arrow R and Q arrow R is the same as P or Q. is the same as P or Q arrow R. Okay? So this is one. Here's another. Okay. Let's just remember the example we did this. If you have 4 quarters, you can get French fries. If you have a dollar bill, you can get French fries. This is the same thing as if you have 4 quarters or a dollar bill, you can get French fries. Anyways, this is true, and they're not asking you if it's true. They know it's true. They just want you to prove it using truth tables. So let's do it. You ready? P arrow R. So this is going to be 1, 1, 1. Whoops. 1. Okay. P arrow. This is going to be a 0. This is going to be a 1. This is going to be a 0. This is going to be a 1. Okay. Let's do Q arrow R. So this is going to be a 1, 1, 0, 1, 1, 1, 0, 1. Okay. And now we do the AND of this. So this is going to be 1, 1, 0, 1, 0, 1, 0, 1. Great. Now let's do this. P or Q. So this is going to be 0, 0, 1, 1, 1, 1, 1, 1. Okay, arrow R. Let's rewrite R. 0, 1, 0, 1, 0, 1, 0, 1. Okay, so let's do arrow. This is 1, 1, 0, 1. By the way, we know the answer we're supposed to get here. It's the same answer because we were told it's true. So this is a little bit, not so terrible. 1 arrow 0 is 0, 1 arrow 1 is 1, 1 arrow 0 is 0, 1 arrow 1 is 1. Okay, main point. This row and this row is the same thing. Therefore, this is all ones. So tautology shows that this is true. That's very nice. Okay, I can see myself asking such questions on the test. This is a very nice question, worthy of asking. 20B. Verify the following logical implication using truth tables. Disjunctive syllogism number 21. Okay, 21. P or Q and not P. Okay, so what is this? This is 20B. Okay, so this is 20B. Okay, let me erase what's in here. We just saved a lot of time rewriting this. Okay, so what's P? What's that? 21. This is just on P or Q and not P. Shoot. We can do it easier. Okay, so this is 20B. It's only two things, so let's do it. Let's just remember P or Q. If I tell you P or Q is true, and then I tell you, just do the letters that they use, not P. Okay? This logically implies Q. Look, if I tell you P or Q is true, and then I tell you P is not true, well, one of them is true. Therefore, if it's not this one, it's got to be this one. It's exactly this. Anyways, that makes sense, but they want truth tables. So we put a truth table. So we're going to do this and that. Okay? And we have only 2 variables, so it's easy to make it up. Oops, you see, I told you I wave 0, 0, 0, 1, 1, 0, 1, 1. Let's do it. P or Q is 0, 1, 1, 1. Not P is 1, 1, 0, 0. And is 0, 1, 0, 0. Okay, so that's pretty good. We already know. Okay, let's just finish it. So this is this is Q. Q is 0, 1, 0, 1. Okay, And now we're doing the arrow. We're going to bring this together with this. 0, arrow, 0 is 1. 1, arrow, 1 is 1. 0, arrow, 0 is 1. 0, arrow, 1 is 1. That's a tautology, therefore this is true. Okay. Okay, great. 20B. 22A. Before we erase, let's look what it is. 22A. Prove or disprove the following. Don't forget that only one line of the truth table is needed to show that a proposition is not true. Q arrow P is okay. So this is so we're up to 22A. Q arrow P is logically equivalent. Q arrow P is logically equivalent to P and Q. P and Q. Okay? That's what they want us to either show or not show. So we don't know the answer here, and we do know the answer. The answer is it's not. But the way we do it is we make a truth table. Okay, so let's do this. Okay, now notice this is going the other way. So here's P, here's Q, but we're going the other way. So watch this. 0 arrow 0 is 1. 1 arrow 0 is 0. 0 arrow 1 is 1. 1 arrow 1 is 1. Great. P arrow Q, P and Q, here we don't care about the order. So this is 0, 0, 0, 1. They are not the same. Conclusion, they're not logically equivalent. Okay? Great. 23. Okay. 23 takes reading. So let's read. Ready? A logician told her son, if you don't finish your dinner, you will not get to stay up and watch TV. He finished his dinner and then was sent straight to bed. Discuss. Okay, so let's just read it. If you don't finish your dinner, you will not get to stay up and watch TV. So let's do it. Let's do it as D for dinner, finish your dinner. So if you don't finish your dinner, then what's going to be? You're not going to stay up and you are not going to stay up and watch TV. No T. Okay? No TV. If you don't finish your dinner, you don't get TV. Okay? Great. Now, he finished his dinner. So he did D. And what happened? And then was sent straight to bed. And he got no TV. Okay? Question. First of all, these two things are not the same. They're not logically equivalent. Okay? But was his mother lying? And the answer is no, she wasn't lying. She just said, if you don't finish your dinner, you're not going to watch. But if you do finish your dinner, I still can say you're not going to watch. So that's cute. So her mother's not a liar. Anyways, it just says discuss. We just discussed it. I won't ask such a question on the test because you'll all just say, discussing is not a good answer. Consider the statement, concrete does not grow if you do not water it. Okay, that's a little, this is going to be painful. Okay, so that was 23, 24. 24. They finish off with these word problems. Let's read it again. Concrete does not grow if you do not water it. Okay, so I think it's like this. If you don't water it, that implies not growing. All right, you should know we should use small letters. Concrete does not grow if you do not water it. So no water implies no not growing. By the way, it's a little bit silly, right? Because concrete doesn't grow. Okay? Grass grows. Concrete doesn't grow. So concrete does not grow if you do not water it. It's a false statement. No, it's actually a true statement. Concrete does not grow if you do not water it. So concrete does not grow. So this is true all the time. No matter what W is, this is true, meaning this is true also. So this is a true statement. Concrete will not grow, no matter what happens. Concrete doesn't grow. It expands, but that's not what the point is. Okay, good. Now, by the way, I could get this wrong. Give the contrapositive. If concrete grew, that means you watered it. That's the contrapositive. Okay, doesn't matter because this is a false statement. I'm sorry, this is a true statement. This is also a true statement because this will always be 0. No matter what, you water it or you don't. So this is always a true statement. So this is a true statement, this is a true statement. Give the converse. Okay? The converse of this statement is this statement. Okay. If it didn't grow, that means you didn't water it. That's not true. You could water it, you could not water it. I don't give a damn. This is still going to not grow. So this will be true, and this might be false. And so the converse is not true. Give the converse of the contrapositive. We had a name for the converse of the contrapositive, namely the inverse. So the inverse of this statement, okay, anyways, it says give the converse of the contrapositive. Converse of the contrapositive. Okay, so one second. This is the proposition. A little bit confused here. This is the contrapositive. Okay, good. Now, this is part C, give the converse of the contrapositive. So this is the converse, oh no, so this is A, this is B. Converse, oh, give the converse, no, they wanted just the converse. The converse is this. Good. Now C. Now C. Give the converse of the contrapositive. So here's the contrapositive. The converse of it is W arrow G. If you water it, it will grow. Well, this is false all the time. So it depends. So this is just as true as this. Which among the original statements and the ones in part A, B, C are true? Oh, so this is true, this is true, this is false, this is false. Okay, and we're done. I might have messed up here, but I think it's true. Okie doke. Have a wonderful day. As always, the other problems in the homeworks are fair game for test questions. Take care. Have a good day.